So I'd like to welcome everybody. I'd like to thank everybody for attending. My name is Brent Allen, and I'll be presenting Overcoming Power Resistance with Cube Formulas. Really, what this presentation is about the state between going from Excel into Power BI, and really how do we get from one to the other. As mentioned, there is a poll, and we will have some interactive features in this, as well as some polls. And it's at sly.do, and event code R076. For those of you who have a mobile device, we have the QR code that's available. And we will be having a couple of polls, as well as the Q&A through through Slido. So what will we be discussing in this? The first thing is the problem, and why do we need cube formulas? If we could do everything, if we could go straight from Excel into Power BI, we really wouldn't need them. But there tends to be problems when you try and do something like that. So we're going to be addressing that. Next is the solution. So how will we actually implement our cube formulas on the spreadsheets, and what's really involved in that? And we're going to finish with the actual cube formulas themselves, and we're going to be going through what is the syntax of the cube formulas and how would you use them on a spreadsheet. So who am I? I would describe myself as a recovering VBA addict. I've been doing VBA for the last 20 plus years. And really, in the last 5, I've been kind of moving towards the Power Platform, Power Query, and Power Pivot in Excel. I've worked in both finance as a financial analyst and in IT as a business analyst. And I am an instructor on the site Pluralsight, where I teach a Excel course there, and we'll have another course coming up at the end of this month in Excel automation. I have my own company where I do independent consulting. It's called MacroOrdinary, which does Excel and Power Platform solutions. The URL will be shared with that at the end of the presentation. So what will this session cover? And really, this session is about navigating those relationships between a finance team and an IT team. We know that finance teams love Excel. They love it. They love VLOOKUP. They love SUMIF. These are the sort of things that finance lives in. IT typically does not. We're going to be also looking into modeling with the cube functions in Excel. So you can see cube members and cube sets. And we are going to be going over what those cube functions actually are. What we're not going to be covering in this session is the modeling in Power BI, as well as DAX and MDX functions. So in this session, the DAX and MDX, as well as the actual modeling in Power BI, will have already been created. Now, we have a lot of other great sessions that are available in this program to do DAX and MDX, and there are a lot of other sites. We will show you that the DAX has been pre-created when we get to the demo section. So we're going to start by going into a company and ask them, why do they need a new reporting solution? And this is an organization. This is a typical snippet of an organization that you would deal with. On the left side, you'll see the finance department. And on the right side, you'll see the IT department. And really, they don't intermingle very much. At the top, there's the CEO. It's important to note, however, they do not have a dedicated department responsible for business intelligence or reporting. So now we're getting into our first interactive poll that we're going to be doing. And this one actually is going to be asking, who is responsible for creating enterprise reports in your organization? Do you have business units who are responsible for creating the enterprise reports in your organization? Do you actually have a dedicated BI team who actually develops reports specifically in Power BI? Does the IT team develop the reports, perhaps in an ERP system? Or do you have something else? Perhaps all of your reports are developed by consultants or consultant teams. So we'll give this a minute for people to chime in. At this point, the business intelligence team seems to be winning. And We seem to have a pretty even breakdown here between the business units developing kind of their own reporting, and then the IT team developing their own reporting. And we may be stopping this in just a second. So it appears that a lot of people have that kind of BI team. And it's a good thing to see that people have that kind of BI function in a sense that reporting is a very, very important element of day-to-day activities. And it's not the sort of thing you typically want just IT or just a business unit to handle. All right, and we're going to stop the poll right now. So in our example, the CEO has asked our CFO, how can we save money? And the finance team here is a pretty lean team. So what they have done then is they have gone and asked their CIO and said, how can your team, the IT team, save my team time on developing reporting? They have a lot of manual reports and think that this is a way that they can achieve the CEO's objective. The CIO has in turn gone to the CIO's team and says, can we find ways to do that automation or improve the financial reporting in order to save money? So the IT team has come back with a plan, and they've looked at the current state. And currently what's happening is that they are extracting reports from the ERP system into Excel files and then developing the reports that way. And the ERP system is not one that we're really going to be investigating in this. We're going to assume that the ERP reports are proprietary and not modifiable. And where they would love to be able to go is to BI reporting. They would love to be able to build their dashboards into Power BI, but really that journey is something that takes a lot of time and effort. And the finance team really, really loves Excel. And that's something that you'll see if you've ever worked with the finance department. They love Excel, and they would love to stay in Excel if they can. So they tried to create this kind of intermediary solution, which is to create a data model spreadsheet. The data model spreadsheet uses Power Query and Power Pivot to bring data from the ERP system into this kind of centralized location and eliminates the manual reporting. So they're going to go report by report, and the first test that they're going to run is a report that looks at the top 10 states and salespeople. It runs quarterly and looks at sales, profit, and profit margin, and uses data from the ERP system. So what is the existing manual process? Well, you export 4 files from the ERP system, the current city by employee, the current quarter by employee, and as well as prior quarter. These files contain sales and profit, and are used in the manual extraction process. They copy the files manually that they've developed from the ERP system, and they copy them into an Excel template. They then take that template, the data that's been in there, and they have a ranking sheet which ranks the necessary information using SUM-IF formulas. And finally, the SUM-IF formulas are then taken through a VLOOKUP system onto a main page, which is then the final report. So why would you want to remain in this manual reporting? Well, it's really easy. A lot of people know SUM-IF. A lot of people know VLOOKUP. There's no additional cost there. It already exists. People are comfortable using it. However, there are a lot of downsides to the manual reporting process. The big ones are you can't get additional history. So you've only got that quarter over quarter. If you want to go back an additional quarter, you have to re-download new reports. You have to copy them. There's a whole manual process. You effectively have to regenerate the report. You can't do any customization, such as if you wanted to drill down to a city or you wanted to drill down to a month. And it's very easy to manipulate the results if you wanted to say, tweak a number on one of those underlying systems. If you chose to show something that you didn't want to, that could be done intentionally or unintentionally. If, for example, you forgot to, you double copied an information, you could end up with a lot of room for an error, not to mention you're always doing this downloading from the ERP. You're always copying, you're always pasting, and there is that huge amount of time required in order to generate the reports. And that's what's really costing a lot of money. And that's what the CEO brought up earlier as the reason why they were moving into the automated reporting. So what's a data model spreadsheet? Well, it's got the same look and feel as our existing report. But instead of pulling from the manual ERP extractions, it pulls directly from the data source, and it uses Power Query and Power Pivot to create that Excel data model in the background. So the big benefit here, it gets that data directly from the data source, and it refreshes the data automatically. We'll be showing later, we'll do a quick demo as well, to port this model into Power BI. It has a straight import function if Power BI is where you eventually go. And this can all be done in Excel. There's no need to purchase any new software. The big downsides of this, you have the development time to develop the new reports that need to be done. If there's any downstream reports where you actually cut and paste the data out of one report into another report, they may require redevelopment. There is training time that's involved in making people learn the new spreadsheets, where to find the new spreadsheets, how to use the slicers on the spreadsheets, as well as audit requirements. And the audit requirements would be if you had a situation where the auditors, you had external auditors who needed to confirm every number because you've changed a process. So we're going to stay on this slide for a minute or two. And this is really a case of what have people come back with. And on the left, you can see the report that was done entirely using manual reporting. And on the right, you can see one that was done using that data model spreadsheet. And we're going to stop here for a second, because what we're going to be looking at is what are the differences between the two. And what I'll remind you is that there is no difference in the data. So don't be trying to dig down and say that Texas's profit margin might be different, because the data is identical on the two of them. And we'll be doing a poll in just a second. So I'm going to stop here for just a second. So look at the differences between the two. And we're going to give about 15, 20 seconds to do this. So just look and see if you can what you can find as differences between the two. Okay. And we're now going to move on to our next poll. Which is, how many differences could you actually see between these two reports? Okay. And this poll is now active. So we got one for 3 or 4, somebody who's saying that there is no difference. We've got somebody who says there's 1 or 2 differences. 3 or 4 seems to be where people seem to be landing at, is somewhere around 3 or 4 differences. We've got one person who's saying none. Nobody seeing 5 or more. We'll see if that one was just a trick that I threw in there to see if we had 5 or more. We're going to be stopping the poll in about a minute. Okay. And it seems like most people have found 3 or 4 differences. So let's take a look and see what how many differences there actually were on the 2 reports. So there are some differences between the 2 that are very easy to find. And you'll notice that the first big difference between the 2 is there is a slicer in the data-driven spreadsheet. Second off, if you look in the existing state, we actually had the missing the date in there in our data-driven spreadsheet. We do not have the date there. And finally, if you look at the sales rank column in our data-driven spreadsheet, this is a measure, so it is actually located within the data, whereas in our existing state, it's in column A. These were the easier ones to spot. There were a couple that were a bit trickier to spot as well. So our data-driven spreadsheet is in a pivot table, and you'll notice that there's a filter icon there, whereas in our existing state, you cannot see a filter icon. And finally, if you look in our existing state, there was a blank row in row 19 because we have a pivot table. We couldn't really add a blank line between our states and our total. So the correct answer to this was 5 or more. So if anybody did have 5 or more, that was correct. So what did the finance team like about our data-driven spreadsheet? And what they really liked about it is that the data was accurate. And anytime you deal with a finance team, that's priority number one, is data accuracy. But what I will say, and this is from experience, is that every time I've implemented slicers tend to be really, really liked by finance teams with that quick being able to move things around. What did they dislike? Well, they didn't like the fact that the report element, that date section, was missing. And what typically they need it for is because a lot of cases, people will take this report, they will print it out, or in 2020, they might PDF it and share it over a Zoom call or a Teams call. But that's something that they like to have, is that element of being able to still have that report available in hard copy. And they need that formatting to be much more precise, and that means no pivot tables. So what they've said is, at this point, they're going to stay in the manual process until their dislikes are resolved. So how can we actually move this data-driven model to a model which can meet our users' needs and remove their dislikes? And they've come up with 3 potential solutions. So the first one is to either create a view in the background or use Power Query, query the data that we need, put it on the spreadsheet, and then continue to use our Excel formulas such as SUMIF and VLOOKUP. The second one is, instead of having the pivot table as the report, we'll have the pivot table as a data source in the background. We'll use getPivotData to pull it, but the pivot table itself will be hidden. And the final one is to use our cube formulas, which is the name of the course, and use those to extract the data directly from the cube. So let's look at the pros and cons of each of these 3 solutions. So the first one is to do that data query, and we are just going to create that view that provides only the data we need. We're exporting all the data that we need into an Excel workbook and just use those Excel formulas. So why do we want to do this? Well, it's easy to find our underlying data on the report. It's available on a tab. Once again, we have the SUMIF, VLOOKUP, simple formulas, and it does provide that advantage over our existing manual process in the sense that it is refreshable data. There are a lot of cons to this. The big one is that, our spreadsheet can get very large because we are extracting all the data. We can no longer use that timeline slicer that people actually did like from the pivot model that we developed earlier. When we're just extracting all the data onto a spreadsheet, then we get a security issue because we've actually now disconnected our data potentially from the underlying source. And if we eventually want to move to Power BI, we haven't developed that data model. We would then have to redevelop all of our DAX. We'd have to redevelop all of our data relationships to do that eventual migration. The second option is to use a hidden pivot table. So we would actually have a data tab available. We would hide the data tab. We'd use a slicer to control that underlying pivot table on our main data tab. And we would refer to our pivot table using the getPivotData formula. The big advantage to this is we are now leveraging our data model. We are actually building an underlying Power Pivot, and we don't need to rebuild all of our DAX and our measures. But there are a couple disadvantages here. Our pivot table needs to be refreshed because we do have an underlying pivot table. If we have more than one pivot table on our underlying sheet, and let's say a name were to change or something like that, and our pivot table were to expand columns or rows in a way we weren't expecting, the pivot tables could overlap, and that would throw an error, which would be especially hard to find because it's on a hidden tab. And then in order to manipulate a hidden data table, you have to use a slicer or potentially VBA. The final one is that cube formula. And the cube formula, what it does is it converts the pivot table into formulas that will refer to the cube directly. And once again, we're going to continue using our timeline slicer to filter the formulas. So like the hidden pivot table, it leverages the data model functionality and uses that timeline slicer. We don't require an additional data refresh. However, there are the disadvantages of some additional coding required. And if you are dealing with a model where you're looking at thousands and thousands of measures that need to be calculated, you are going to be looking at a refresh performance that is slower than just using a pivot table. So let's get started building our cube formulas. So this is our sheet that we are used to seeing, and you'll see on the left side we have our quarterly sales by state and our quarterly sales by salespeople, and our date is missing. So we're going to start by building our first cube formula, and we're going to build it in cell A3. And the first one we're going to build is called the cube value formula. And if you put in a single quote, it will IntelliSense, and if you look right below A4, it brings up this workbook data model. And this workbook data model is how you will refer to every single, when you're using an Excel data model, that will always be your first argument in any cube formula. And what we're looking here is we're looking to bring in a particular measure. And I'm going to actually go and look into our data model itself. And if we look here at the data model, and it'll just take a second to bring up the data model. And we've established it's a pretty simple model. It is a star schema with our fact in the middle and our city, employee, and date around the sides. And as far as the report date, we have managed to make a measure for that. And if we look here in our measures, there's one called selected date, and it pulls just the minimum date to the maximum date. There's no additional filters on that. So that should actually pull in Q3, the dates that are required. So I'm going to develop my cube value formula. So you'll notice that IntelliSense once again picks up our 4 tables that we have there, including an additional one for measures. And I'm actually going to pick the measures selected dates. That will bring in all selected dates. So we want selected dates that are filtered by the timeline slicer. So we're going to add in a second member expression, which is the timeline date. You'll notice that it will actually, the IntelliSense will identify the names of the slicer based on the object name. We'll close that. And now if you look in A3, it has been created, the proper name, the proper dates for the period. The first one that we'll look at as far as our 2 pivot tables is converting is our quarterly sales, which is listed by salesperson. And if we go up into our pivot table analyze, there's actually something called OLAP tools. And under OLAP tools, there's an option to convert to formulas. If we go to OLAP tools and convert to formulas, what it will do is now, while this one is still pivot tables, these ones are now actually all formulas. You'll notice up in the formula bar, you can see cube values and cube members. So what we're going to do on this one is, and this is still fully reactive to the slicer. One of the neat things about the cube member, so the cube member will bring in the names up top. So you'll notice the names for the employee. You'll also notice the names of the measures. And one of the things that we have when we look at a pivot table is that you'll notice that they've all been now renamed to the actual name of the measure, total sales by salesperson, total profit by salesperson, and so forth. You could actually attach an alias to that under a caption. So here we want to rename this sales. And we want to rename this one profit, for example. And what you'll notice is that in the spreadsheet, the actual measure itself looks like it is named as we've named it based on the alias. In the cube value formula, it will actually pull in that based on that cube formula. It'll pull in based on the name, the measure, as well as reactive to the slicer. At this point, we would probably be moving that around. So what I'm going to do is I'm going to move forward to something where I've actually gone and fixed the formatting already. And what we've done, you'll notice, is that the cube value here, now this uses a rank X formula, and this is actually a measure. So normally a measure would have to sit in the middle of a table beside a cube member, but we've managed to move that back to the top. And even though we've done that, we can actually now have our slicer change, and that rank X formula will modify. But what you'll notice with the salespeople is the salespeople are still fixed, even though the ranks themselves have changed. If you want to actually change those, you actually have to then do a manual sort. And where you would use this kind of cube member is if you want to do something where you wanted to have, say, a specific order. For example, let's say Archer Lamble was the senior VP of the department and has to be first in line. You can use these cube members to ensure that the order is maintained. Now we're going to go back to the other one, and because states are a little tricky. We only had 10 salespeople, which made it easier to only have 10 there, but we have more than 10 states. And the other thing is the states change every quarter based on the sales. This is still the top 10. So we're going to need to use a little bit of a different approach here. So we'll start by still doing that same OLAP conversion to formulas. But what we'll actually have to do here is define a set. And what a set does, and I've created a formula here, and it uses something called cube set. And we'll be going through the syntax in a little bit more depth. But what it does is it actually goes and says goes into the state province and says, give me all unique members of that particular part of that cube. And we're going to sort it in a very specific fashion. We're going to sort it by total sales and state. And then we're also going to filter that based on what our timeline shows. Unfortunately, with this particular model, the particular formula, you actually have to, you can't use a slicer, you actually have to use a measure. So what we've done is we've actually said, let's develop another measure to get our currently active quarter. And we put it into A4 and made it blank. And what it does is it says, give me what is my current quarter. And then I can use that as part of an element in my formula. You'll notice that it just says A4. We don't have to hard code everything. We can actually continue to use Excel. Now, if I want to go and say, well, what was my number one state during this particular quarter? I use another formula called CUBERANKEDMEMBER. And I continue to use this workbook data model. My set expression up there is that, and it's the actual set that I've defined, and the rank would be 1. And what I've done then is said, what is my number one sales in that particular quarter? And it will actually go and bring that in. And if I look here at my finalized model, so we have these set up, and we've developed that. And what we've done is we've brought those all in, and you can see that as I change the quarter, and if you look in column B, the states change based on the sales. So the sales are always properly sorted. Now, let's say that people are happy with this report. This perfectly meets the needs, but in the long run, you want to convert this to Power BI. So we're going to actually close out of this, and we're going to go into Power BI. And in here, you can actually go into import and say, let's actually open our Excel model, So our Excel model demo. Oh. And let's close this one down. Just be a second. And we want to open this. And it will actually go here, and it will import the entire data model as well as all your DAX measures, all your relationships. So when you're looking to eventually convert these Excel spreadsheets into Power BI, you can do that. You'll notice on the left side, your fields are all there. If you look at your measures and you were to look at your fact sale, that our measures, our profit, our sales rank measures have already been completed. You can see that the DAX is still all there. If you look into your relationships, the relationships have already been set up, and you are now can use this to really get a big head start on your Power BI deployment. So now let's go back in here, and we looked here in our cube formulas at two separate approaches. So the first one we looked at was when we did our employees, and that is where we used our cube members to define our specific names from a table field. The next one we looked at was our cube set formula, where we actually defined our group of items from a table field, and we sorted them accordingly. In our fixed cube members, they're really easy to create using that OLAP tools feature. And they're really good for those small, non-changing dimensions. So in there, we only had 10 salespeople, so it really worked. And the other reason you would use this is that whole being able to manually sort members within there. If you wanted to have, say, geography and you're going west, northwest, south, east, there may be no natural way of sorting that information without having to create a new table, new relationships. And this is a quick way to be able to do that sorting. However, if you have something that's rapidly changing, where you're adding new customers or something along those lines, you don't want to use this approach because you could miss that information, and you can't do that automatic sorting the way that you would use the cube set. When we did the ranking using the cube set, it's great for those dimensions that can contain the new members, and you can do that automatic sorting as we showed with the states, where we were sorting it by the value of sales. However, these are a lot more complex, and we can't automatically create those using OLAP tools, and we can't do that kind of manual ranking. We would always have to be able to do that automatic ranking. And one thing I will say with respect to that set, before I move on, is that syntax isn't necessarily as easy with the IntelliSense that's in there. So let's go on to the actual formulas themselves. And there were 4 that we discussed in this course. And these are really the 4 that you will use most often when you're dealing with an Excel data model. So the first one is that CUBEMEMBER, and it's really used to get a non-value item from the data model, like a state, like a salesperson. The next one is the CUBEVALUE, and that's used for getting those aggregated values from the data model from a measure. The CUBESET is to get all the unique values from a field. And finally, we would rank those using the CUBERANKEDMEMBER. So let's start with the CUBEMEMBER formula. So we used this in our example to get the salespeople. The first one was always this workbook data model. Anytime you're working with an Excel data model instead of an SSAS, you will always be using this workbook data model. And the member expression can either be a data member from the cube. So for example, if you said you wanted to pull Texas, you would say, dimension city dot state dot ampersand Texas, or you could use a measure name. So measures total sales by state. And really, when you're using measure names, that's where you get that real extra ability to add in that caption, that alias. Whereas if you were using a pivot table, if you want to have multiple values with the same alias on them, you have to kind of trick the pivot table. So if you wanted to have sales by quarter, year-to-date sales, the way you would do that is sales, space, and in order to properly show just the word sales. And when you're looking at other formulas, such as your CUBEVALUE formula, it will refer to that member expression, even if there's a caption in place. The most commonly used one you'll have is that CUBEVALUE formula. The member expression first one needs to be a measure. So we used ones like sales. We used We used profit margin, things like that. But everything after that can be your slicers, your timelines, your cube members, to really filter that measure down into what you need it to. And eventually it will actually run that measure based on the measure, as well as all expressions that you've added to filter it thereafter. The cube set formula, what we'll normally be doing is pulling information from a field or a slicer. And if you're using a field, and this is something that can really trip you up easily, is your IntelliSense will pick up the name of the table, it will pick up the name of the field. However, you have to add .children at the end if you're using a field, and IntelliSense will not pick that up if you're trying to use that. If you don't set a caption, it's just going to show up as a blank cell. But don't worry, you've actually done the work to get your cube set. You can define a caption. So if you are looking at something, for example, with states, you can say states, and that will contain the one cell states will contain all the information. Your sort order at the end can be alphabetical, numerical, or based on a measure that you've defined. Finally, you have your cube ranked member. And what cube ranked member really does is it says, we've defined a set. We're going to pull an element out of that set based on the rank that it's located in. If you were, for example, to sort by the sales by state, your number one sale was Texas. Your rank is 1. And as a result, you would see the word Texas as your cube ranked member. Finally, what we did in this is we took our model and we imported it into Power BI. So we took our data model, we took all of our underlying data, and once we built that, we imported it into the Power BI using the import function and the Power Query, Power Pivot, Power View. Important to know here is that you have to use this import Power Query, Power Pivot, Power View, not get data from Excel. You're actually getting the model. You're not actually getting, say, a table within Excel. That's something that can trip you up if you are trying to use that import model into Power BI. So what did we learn in this session? Well, we started by identifying why you would need to use these kind of cube formulas. It's really to create that transition to go from a manual process when you're not quite ready to go into full Power BI yet. When we experienced some snags with the Power Pivot tables, we proposed some solutions like creating an underlying data extraction, as well as hidden pivot tables, as well as finally we looked into the cube formulas. And then finally, we created our cube data model spreadsheet, which involved using the cube formulas. We used our OLAP tools to do that conversion, and then we imported our model into Power BI. So I'd like to thank everybody for attending. I have a blog at my site, which is macroordinary.ca/blog. You can find me on Twitter at macroordinaryca. And at this point, we'll be taking any of the questions that have come in through Slido. So let's see what we've got. So the first question, which everybody seems to want to know what my favorite cheese is, it is Parmesan. I do like that. The other question is, can I use these functions to reference a different model like like SSAS or a Power BI data set? SSAS, absolutely. This was the cube formulas were actually designed originally to be used in SSAS. The formulas actually go back to 2007, which predates Power Pivot. The difference, if you were to use SSAS, is instead of using this workbook data model, you would actually be using your SSAS data model in place of that data model. Do we have any other questions?
Yeah, so Brent, this is Matthew.
Yes.
There was quite a lot of chatter about this solution, but no questions coming in via chat or via Zoom Q&A. One thing that Donald mentioned, so it sounded like Donald had a lot of familiar experiences that align with yours. And he mentioned that that he would rather use pivot tables because of users messing up formulas if he's using cube formulas. And there's an implied question in there, which is, how would you prevent a user in an Excel workbook from accidentally or deliberately editing the worksheet where those numbers are displayed? Are there any ways to have more control over that?
You could use, you could actually use, within Excel, you could use cell protection, potentially. As you get closer to that, you would probably be, just because eventually what could happen is modification would throw things off. Where you want to be is you would need to use some VBA in order to properly control that. But that's really where I'd start, would be to actually use cell protection. And if you were to use cell protection, it would be up in your review tab, and you would actually go in to protect your worksheet.
And that would basically be a way to protect from accidental modification. It wouldn't really be true security.
That is correct.
Cool.
We're not looking at full-on data security by just using a worksheet protection.
Excellent. And for we just got a question coming in via Zoom Q&A. This question is from Mike. So Mike says, I keep hearing this day that we may not need SSAS because of Power BI and all the reporting tools that can do what the cube do. He's looking for information on the relationship between Power BI and SQL Server analysis services. And I'm not sure how well this aligns with your question, but for the customers that you work with as a consultant, how many of them still have analysis services hosting their model? Who's hosting their models as Power BI data sets? And what's your experience there?
Yeah. Yes, SSAS really is not my specialty, so I'm afraid I can't really answer that question as far as when it comes to SSAS. Yeah, that's not something. Really, my focus on this presentation was kind of that relationship between Excel data, underlying data, and less about that SSAS level.
Cool. So thanks for that. And so this is the full set of questions that we have. So I think that I will go back on mute. I'll hand this back over to Chris as the host to wrap things up. And thanks again, Brent. This was awesome.
Thank you very much. Thank you, everyone, for attending.